This is the Daily Space for today, Friday, June 26th, 2020. I'm your host, Dr. Pamela Gay, and I am here to put science in your brain. Over the years, I've read a lot of papers and press releases, and at a certain point, I honestly started to think nothing could surprise me anymore. Today, the universe proved me wrong by presenting something glorious that I could never have imagined. The Hubble Space Telescope has imaged the changing shadow of a planetary disk on background dust and gas clouds. And like shadow puppets, it appears that there's a bat flapping dark wings out in the cosmos. Astronomers studying the young star HBC 672 made this discovery entirely by accident. It had previously been known that the star has what has been nicknamed a bat shadow behind it in the Serpens Nebula. This shadow is cast by the star's planetary disk, which blocks a band of light. That flapping, that is the eddy of a planet moving around the star in that disk. This amazing change in light and shadow was seen serendipitously in data that was taken over 404 days. The team had requested images of this region in a variety of filters, and because of how Hubble schedules time, these images were acquired over 13 months. It was in trying to create a final image by combining the data that this motion was revealed. This data wasn't designed to study this phenomena, so our understanding of the system is, well, shadowed as best it can be measured. This newly discovered baby world is orbiting no faster than every 180 days and is about the same distance from its star as the Earth is from the sun. This discovery carries on a recent theme that worlds form fast. This star is just 1 or 2 million years old, and already it is host to at least one world. This work was published in the Astrophysical Journal and was led by Klaus Papapetan. Now, if any one thing defines astronomy in this first half of 2020, it's our progress in observing planets and planetary forming disks. This data is reshaping how we understand planetary formation, and the data is coming at us fast and furious from all directions. The results we're seeing today are the result of work that started many years ago. The pace of science can be slow, with each new investigation requiring time to apply for funding, time to build the instruments, time to acquire the data, and time to do the needed analysis. As we've pointed out before, the Bepo Colombo spacecraft was named in 1999, and it will only reach its target of Mercury in 2021. Science is slow. In planetary science, the Gemini Planet Imager has spent the last 4 years providing the sharpest images to date of the disks around young stars. In a newly released catalog of 26 debris disks, most of which show evidence of planets, and some of which even contain evidence of comet belts. This survey will produce new scientific understanding for years to come, but has already started to make sense of some aspects of planet formation. For instance, the youngest star in this collection is also the only one not to have a hole in the center of its disk. This matches theories that say it takes time for planets to clear out the insides of solar systems. And this will start to put constraints on when things happen in solar system formation and help us understand the story of our system's own formation. Unfortunately, we can't go back in time. We may never understand the details of our origins. This is expressed by study's second author, Paul Callis, who said, "If you dial back the clock for our own solar system by 4.5 billion years, which one of these disks were we? Were we a narrow ring, or were we a fuzzy blob? It would be great to know what we looked like back then to understand our own origins." That is the great unanswered question. This work was led by Tom Esposito and appears in the Astronomical Journal. Now, our final story of the day looks back not at the history of solar systems, but rather at the history of Mars. In new research led by the Planetary Science Institute's own Alexis Rodriguez, there is new evidence that asteroids impacted ancient Martian glaciers, and the resulting splash, for lack of a better term, drove water and dust into the Martian atmosphere. According to Rodriguez, something unique happened on Mars during this early phase in its history. Most of the planet's impact basins formed. The formation of these gigantic structures, hundreds to 2,000 kilometers in diameter, would have produced extremely powerful winds and would have also most likely triggered transient climate change conducive to rainfall. The winds could have dislodged from the surface vast volumes of dust that existed when the impacts occurred, resulting in dust-laden atmospheric conditions. We suggest, Rodriguez continues, that when rainfalls happened, large amounts of the dust were removed from suspension to be deposited as thick sedimentary units. An interesting implication of the muddy rain hypothesis is that this process could have emplaced enormous volumes of wet sediments over the planet's extremely cold surface environments. In the likely presence of salts, the water-soaked mud might have produced immense aquifers with low-temperature freezing brines. Put another way, this process could have created reservoirs of salty liquid water, while at the same time building up immense mudstones that we see today. This work has a lot of cool implication for Mars' former water cycle and even potential habitability. We're going to invite the team members who did this work to come on as guests so they can explain this work in their own words. For now, you can check out their paper in the journal Nature. And for now, that rounds out this show. This is all the news we have. This has been the Daily Space.